This video will demonstrate how to use the approximation method to simplify finding equilibrium concentrations when you're given a reaction initial concentrations and the equilibrium constant for a weak acid. So in this case we're looking at lactic acid, and we have the reaction written out here. So we just have to set up our ice table for the initial, change, and equilibrium concentrations. We're given 0.5 molar, and we have no common ions to speak of. So everything is 1 to 1, so we will lose 1 mole here and pick up proportionately 1 mole in our products. At equilibrium, this is just the sum of these two lines. And so now we write out our Ka expression. This is going to be the hydrogen ion concentration and the lactic ion. There we go. And then there's lactic acid. So we substitute in our values here. 8.3 times 10 to the minus 4. And we have x times x up top and 0.50 minus x at the bottom. The approximation method says that if x, the amount that we've used up, is very small relative to the starting amount, then we can rewrite this by saying 8.3 times 10 to the minus 4 is going to be equal to x squared, multiplying these, divided by 0.50. So we neglect this amount. Now, neglecting that allows us to simplify the math greatly, and we're left with 4.15 times 10 to the negative 4 equals x squared, and that means taking this out, we get 2.0 times 10 to the negative 2 for our value of x. And so now all we have to do is compare this, and we find that 0.02 divided by 0.5 is going to give us 4%. So this is less than 5, so the approximation works. And so since this is a success, we can use this as our value of x. That solves the whole thing. If you follow through with the quadratic formula, and you'll find that x is 1.99608 times 10 to the negative 2 at 2 sig figs. That means that x equals 2.0 times 10 to the negative 2. So the quadratic formula, while longer, will give you the same answer. Because we're looking at something that's less than 5%, we can simply use the exact same result from the approximation.